topic today, that is cloud overview. In this one, I am going to talk about the on-premises working culture. On-prem working culture. What is on-premises? How the people in the on-premises usually work, and how the cloud will work, and what is the difference between the on-premises and cloud. And that's where we are going to talk about it. And after that, basics of the GCP again we are going to see. Okay, so this is the agenda for today's session. So without any further delay, so let us start and jumping onto the session, guys. As you guys now know, actually my name is Sheikh Saidul, guys. The name is, I'm joined with a different name. Okay, so my name is Sheikh Saidul. Yeah. Now the cloud overview. We are going to see why we need the cloud platform. What is the difference between the on-premises and work cloud platforms, right? So let me gonna go to that. Tell me why we need the cloud platforms. Anyone? Can you guys guess it? Why we need the cloud platforms? Let me gonna talk about that in a with a very simple example, so that you guys everyone will understand that. Okay. So let us consider a company. Let me take a simple company, any company, a company called ABC. What this company wanted to do is that they wanted to create one application for their end users. For their end users, what they wanted to do is that they wanted to create an application, right? Let us consider a company, an organization wanted to roll out a new application for their end users. So what are the things comes into the picture when you are following a on-premises methodology? All of those things, let us try to see it here. Let us try to understand it here. For example, if a company wanted to roll out a new application for their end users, what will happen? Let us try to see. For that one, so whenever you wanted to create an application for your end users, the business comes up with a requirement for the application. The business comes up with a requirement for the application. Then there is a business analyst will be there. He gather all the needs from the business and he analyzes that and converts that into a set of high level technical requirements and passes that information to the solution architect. What will happen, sir? Whenever you wanted to create an application, the business comes up with a requirement for the application, and the business analyst will gather all the needs from the business and he converts that into a set of high level technical requirements, and then he passes the requirements to the solution architect. Now the solution architect is the one who designs the architecture to be followed for the deployment of the application. He creates an entire architectural diagram. He creates an entire architectural diagram, right? So that is required for you to create this entire application, right? So a solution architect, what he is doing, he gets the requirement from the business analyst, and according to the requirement, according to the use cases, or according to the end user experience, what he will do, he create an entire architecture diagram to be followed for the deployment of the application. This may involve a plenty of infrastructure. Usually, if you wanted to create an application, you need two things. Usually, if you wanted to create an application, you need two things. One is code, one more is infrastructure, right? So if you wanted to create one application, you need one thing, that is code. Code has to be developed by the developers, and infrastructure has to be set up by the company. The infrastructure has to be set up by the company, right? So that's so what the solution architect will do is that he will design everything and keep in mind from the requirements, and he will design an entire architecture diagram and what procedure they have to follow, what code language that they have to follow, and what are the number of infrastructure that is required in terms of the servers, how many number of servers that are required, and front-end web server, back-end databases, load balancers, everything that are required for you to develop. So all the infrastructure details he will mention it. All the infrastructure details he will mention it. And code will be developed by the developers. The infrastructure, now tell me guys, Who has to create this infrastructure? Who has to create this infrastructure? What the solution architect has done, according to the requirement from the business, he created an entire architecture to be followed, which is providing you the details about the code and how it has to be developed and the infrastructure that is required for the application to be ready, right? In terms of the databases, in terms of the storage, in terms of the load balancers, and everything that he has mentioned. Now tell me, guys, who has to create this infrastructure when you are following a traditional methodology? Who has to create this infrastructure? When you are following a on-premises methodology, who has to create this infrastructure? Who has to maintain this one? So when you are following, yes, when you are following a traditional methodology or when you are following a on-premises culture, this entire things has to be created by that particular company. The company has to maintain the data center, right? Because this entire code and infrastructure has to be deployed on top of the on-premises data center only, the company's own data center. Think like this one, we do not have any cloud platform now. You are working in 2000 era. In 2000, 2001, 2002, people were following this methodology only. At that point of time, you do not have any cloud. So what they usually do in that particular company, they manage their own data center. In that particular company, they manage their own data center. In that particular data center, they make sure that whatever the infrastructure that are required, they will keep it here. In that particular data center, whatever the infrastructure that is required, they will keep it here. Tell me, if the infrastructure that is required for this application is not available in the data center, what they have to do? Right, sir? He has created the architecture diagram. It requires some 100 number of machines, for example. In a simple word, some 100 number of machines required, but only the 50 machines are available here. What about the rest of the 50 machines, guys? If you do not have a 50 machines, you cannot have your application ready. So tell me, guys, what if the additional hardware is required? What they have to do? What the company will do? You know, the company will order it via procurement team. You do not have any cloud platform, so everything you have to manage. You have to manage your own data center, right, sir? If you need some 100 machines to deploy your application, if the out of 150 machines are only available in the data center, if rest of the machines are not available in the data center, or if any additional hardware is required for you, if any additional hardware is required for you, you have to order it via procurement team. You have to order it via procurement team. Now the procurement team will put in a request to the vendors team. They will put in a request to the vendors team. Now the vendors team will visit the hardware shops. They purchase the machines and they deliver it to the data center. They deliver it to the data center. So this is what will happen, right? So whenever there is a additional hardware requirement is there, they have to order it via procurement team. Now the procurement team will put in a request to the vendors team. Now the vendors team will take days or weeks, even sometime months also for the entire hardware to be purchased and deliver it to the data center. Right? So this is what it is, guys. So far, this is what we are seeing, right? So if any additional hardware requirement is there, right? So you have to, the entire infrastructure has to be available in the data center. If it is not available in the data center, they have to order it via procurement team. Now the procurement team connects with the vendors team. Vendors team will put in a request to the, now the vendors team will visit all the shops. They purchase the entire hardware and they deliver it to the data center. Now all the machines are available here. But sir, once the machines are delivered at the data center, can we directly use them? Can we directly use them? No, you cannot directly use those machines because the machines has to be installing an operating system. So what they will do is that whatever the infrastructure or hardware delivered at the data center, right? The field engineers will come into the picture. They will take a charge of rack and stack equipment. They will arrange this entire hardware in the form of a rack and stack, right? So you might have seen here the picture. So this is how the rack and stack looks like. Once the entire hardware is delivered at the data center, what will happen, sir? They will arrange the entire hardware into this rack and stack. You see, this is what we call as a rack and stack equipment. So they will place the entire hardware in this particular order. That's the reason you need the field engineers. That is what is the field engineers will do. Once the field engineers has completed the rack and stack equipment and arrangement, then system admins will come into the picture. They will do the initial configuration of the system. Every system, every machine has to be initially configured with some configuration. Once the initial configurations are completed, the network admins will configure the networks. They will assign the networks also, so that all of these machines are available over the network, right? So the network admins make sure that all of these systems are available over the network. And then storage admins will come into the picture and they will assign the storage to your servers, right? The storage admins will assign the storage, and then backup admins will assign the backup, right? So these many people working behind the scene in the on-premises working culture. Okay, so when you are following a on-premises working culture, so these many people working behind the scene, right? You see, once the hardware is delivered at a data center, the vendor's team is delivering at a data center. The field engineers will take care of the rack and stack, and the system admins will take care of the initial configuration of the system. That network admins will take care of the network configurations, and the storage admin will assign the storage admins will assign the storage, and the backup admins will assign the backup. Once everything is ready as per the standard that is mentioned in the solution architecture diagram, once everything is ready as per the architectural diagram, whatever the code that they have developed by the developers, that's where the application team, nothing but a developer team, whatever the code that they have developed, they are going to be deploying on top of this infrastructure which was created, and your application is now successfully running in the on-premises data center. That's where end users can able to connect it to your application. So this is the process. See, so when you are working in an on-premises working model, these many different teams, different people, different processes comes into the picture. If they all work together, then only a final output that will come into the picture, that is your application, right? So if you can see high level, if I wanted to tell you one more time, right? So whenever you wanted to create an application, the business comes up with a requirement for the application. The business analyst will gather the requirements and passes that into high level technical requirements, and then he passes that information to the solution architect. Now the solution architect will design an architecture to be followed for the deployment of this application, and it involve both development details as well as infrastructure details. Development details will be taken care by the application team, but infrastructure details has to be done. So the entire infrastructure is already available in the data center, well and good, no issues at all. But if it is a additional hardware is required, they have to order it via procurement team. The procurement team will connect with the vendors team. Now the vendors team will take a lot of days, weeks and months also sometimes to purchase it and deliver it to the data center. Once it is received at the data center, the infrastructure team will come into the picture. They will do the they will do the rack and stack equipment. System admins will assign the system configurations. Network admins will take care of the network configurations. Storage admins, backup admins. Then finally, if everything is ready as per the standard, that's where the application team comes into the picture and they do the deployment of their code on top of this infrastructure. Your application is ready, right? So this is what is a on-premises working culture. Telling me like this one itself, it is a lot of process for me, but think about it in a real world, how people were taking a lot of challenges, how people were working in this particular culture, making everything ready. A plenty of the application in 2000 2005 until 2005, plenty of the companies were following this kind of an architecture only, this kind of a methodology only, which we usually call it as a on-premises working culture, right? So that's how. Now tell me, now that you guys know about this process of on-premises, what are the challenges that you guys see here? What are the problems that you guys see here in on-premises? Can you guys guess it? So I'm going to put it into again the same format so that you guys can understand the challenges from the on-premises working model. The very first one is slow deployment model. One was mentioning already, it is taking a lot of time, sir. Yes, because you see, sorry, because you see it is a slow deployment model because many people, right, working behind the scene first thing, and the turnover time varying from the weeks to the months, because sometimes these people are not ready, and sometimes purchasing and delivering may take a lot of time, sometimes the field engineer is taking a lot of time. So because there is a dependency between all of these people, the turnover time varies from weeks to the months to everything to be ready for the application deployment. So that's the reason I'm calling it as a slow deployment model. Can you guys agree or not? Do you guys agree? Yes. And the same thing, one more point is the cost. One was mentioning, sir, it is a very costly process. It is an expensive process because the overall cost to maintain this model or the overall cost to deploy this particular application is very high. The overall cost to deploy and maintain this model is generally high. So that's the reason I call it as an expensive model. Do you guys agree again? Yes. One more thing, the automation is limited. Some of the aspects can be easily automated when it comes to the infrastructure, but several steps such as rack and stack or the purchasing and delivering, so such kind of things cannot be actually automated. So that's the reason some aspects of the infrastructure can be automated, but several steps cannot be automated. So that's the reason I usually call it as a limited automation. I usually call it as a limited automation. One more thing, human error is very high because now you see a different teams working on a different task. The chances of the human error is very high. The chances of human error is very high, which results into the inconsistency in the environment, which result into inconsistency in the environment, right? So a lot of people working behind the scene on a lot of different tasks, the chances of the human error is very high, and it may result into the inconsistency in the environment. One more, a final disadvantage is there. Can anyone guess it? Right? So underutilization of the compute resources, that is nothing but the moment you are purchasing a lot of machines but you may not be using it 100%, that is nothing but wasted resources, isn't it? That comes under the wasted resources. You may be purchasing a lot of machines, but you may not be using it 100%. That is called as a underutilization of the compute resources, called as wasted resources. You are wasting the resources. So these many challenges are there. These many challenges are there, guys, when you're working in a traditional model or when you're working in an on-premises model. These many challenges are there. Tell me, when you have these many challenges, when you have a lot of challenges, what do we do, sir? What do we do? We try to look for an alternative solution. We try to look for an alternative model of working culture. That's where cloud came into the picture. That's where cloud came into the picture. Due to these many advantages over the past decades, the organizations were looking for an alternative solution. That's where the clouds came into the picture. And the cloud computing models, what they say is that the cloud providers, what they say is that don't worry about the infrastructure. We will take care of the infrastructure. Rest of the things you focus on it. That means you focus on the innovation. The moral of the cloud providers, are the main title or a headline for the cloud providers is very simple. You guys focus on the innovation, we take care of the infrastructure for you, and you pay as you go model. How many resources you are using it, you pay it for it. So that's the reason most of the cloud platforms, AWS, Azure, and GCP, these are the leading cloud providers. What they say is that they take care of the infrastructure, we focus on the innovation. They take care of the infrastructure, we focus on the innovation. So what is the advantage, sir, when you are having that, when they are taking care of the infrastructure? So we don't have to worry about the slow deployment model, isn't it? The infrastructure is readily available for us. So you don't have to worry about slow processing, slow deployment is not required, because the process of deployment is faster now. Faster delivery cycles will be there. One more thing, you only create the resources that are required for you, and not many teams working behind the scene. So that, because you do not have this team when you're working in the cloud, you do not have this team. No, 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 no. Development team will be there. No data center. So these many things are not there when you are working in the cloud platform. The data center itself, it is very costly. Maintaining the data center 24/7 electricity, 24/7 security, 24/7 water supply, itself it is a huge cost. Itself it is a huge cost. So now you don't have to worry about it. So that's the reason the cost is very less compared to the on-premises. In the cloud platform, the cost is less. And again, the cloud providers and the provide you the cloud computing services. These services actually work everything via API. Almost all the services working via API. So if something is working via API, the automation is very high. The automation is very high. You can automate the things very high, because every service providing you an API, exposing their data in the form of an API. So you can connect it to that API, you can automate the most of the things. So the automation is in the cloud is very high, guys. So that's the reason you do not have that challenge also here. Automation problem is not there. And now if you can see, not many teams working behind the scene. I do not have this team, this team, this team, this team. So that means very less teams working behind the scene. The chances of the human error is comparatively less, I can say. The chances of the human error. When you're working in the on-premises, many teams were there, but when you're working in the cloud, the number of teams are reduced now. So that's the reason the chance of human error is also reduced. The inconsistency also reduced. And one more thing, in the cloud, we have one of the feature called scale up and down. In the cloud, every service is scalable. And as per the demand, if you wanted to scale up or scale down, they provide you one of the feature called auto scaling. That is nothing but, if your resources are required, that is nothing but, if your business is at the peak, you need more resources, you can scale up. And your business is not doing well, you can scale down. So that's the reason the number of wasted resources are less here, because according to your demand, according to your requirement, you can scale up your resources or you can scale down your resources, so that you will only be using how many resources that are required for you all the time. So which is reducing the wasted resources, which is increasing the utilization of the computer resources, right? So such kind of a problems are fixed by the cloud platform. So that's the reason, sir. That is the main reason nowadays every company moving towards the cloud. Every company is started using the cloud already. Okay. Yes. I hope this is clear. And if you can see, this is what is our entire diagram looks like. When you're working in the cloud, you do not have any of these things. Okay. Yep. So this is what it is. So if I wanted to high level, if I have to tell you again, so what is traditional versus what is cloud? Traditional nothing but on premises. Cloud is nothing but cloud computing. So in a traditional model, your organization managing its own power and infrastructure to run their code or an application. That is nothing but, what is on premises? As I just told you, if you wanted to create your application or if you wanted to execute your code, your company has to manage their entire infrastructure. Your company, an organization managing its own infrastructure to run their code and application, that kind of a company is called as an on-premises working model company. Sir, what is on infrastructure? Every time you say infrastructure, sir, can you tell me what is mean by infrastructure? Most of the people already know, but if you do not know, sir, infrastructure is can be a servers, can be a hardware, can be a software, can be a networking, can be a storage. So all of these things we combine, usually call it as a infrastructure. Servers, hardware, software, networking, and storage. So if this infrastructure is managed by some other cloud provider and you focus on the innovation, and that kind of a company usually following a cloud computing model. In a cloud computing model, the cloud provider managing the infrastructure for you, the innovation is taken care by your organization. That kind of a company is following a cloud computing model. Okay, so that is what you have. Two models. One is on premises or traditional model, one more is cloud computing model. In a cloud model, your cloud provider, whether it is GCP or Azure or AWS, they take care of the infrastructure for you. You focus on the innovation. But when you're working in the traditional, you have to focus on the innovation. You have to focus on your infrastructure also. Both. Your company has to take care of both. Okay, so that is what it is. I hope this is also clear. So Google Cloud Platform is a suite of cloud computing services offered by the Google that offers a range of products and solutions to help the organizations to build, deploy, and scale the applications and services in the cloud. Sir, how the GCP interface looks like? Sir, how these plenty of services, how it is providing and where it is providing, if you want me to show you. So let me go to the Google Cloud Platform and show you guys. Don't worry about it. I'm going to show you how to create this account. Okay. I'm going to tell you how to create this account maybe tomorrow. Right. So, but focus on it. This is how the interface for the Google Cloud Platform looks like. So here, this is a left navigation menu. This is a project area. This is a search box. You have a plenty of options. See, I'm using the free trial only. You see, I'm using the free trial only, guys. I will also tell you how to set up a free trial account. Just wanted to show you how many services and products it is offering. So that's the reason I come here. So if you go to the left navigation menu, if you click on the solutions and you see all products, just click on all products. So you will get to know all the products that is provided by the Google Cloud Platform. If you can see, there are almost 45,000 products are there in the marketplace. 45,000, sorry, 4,500, 4,500, right? So you can see it is providing you management services. These are all services. Compute services, storage and database service, storage services, analytics services, network services, distributed cloud services, serverless services, database services, observability, operations, security. If I just talking about, there are plenty of things will come into the picture. CI/CD and artificial intelligence, integration services, tools, Web3, all of these things. Google Cloud Platform is offering you a plenty of products and services in its marketplace. You can just, if one wanted to use any of the service, they can just come here. For example, if I wanted to, uh-huh, they will provide you a different set of services, but the nomenclature is different. The way that they provide you, the purpose is same. Okay, the purpose of a uh, cloud platforms is same, but the way they call the name, the way that they have developed that particular tool is different, but the purpose is, for example, you call it as a cloud SQL here, there you call it as a AWS RDS, relational database service. The names are different, but the set of services that is offered by the all the cloud platforms is same. Yes, right. Yeah. Now, sir, if I wanted to work with any of the service, I can just come here and I can search for it. For example, if I wanted to work with the data flow, I can search with data flow and I can go to the data flow service. Okay, so we can able to create our pipelines and templates, and you can able to see your everything. So the interface is very simple, I'm telling you. And I will talk about more things just to show you how many number of services it is offering. And this is how a simple interface it looks like. Very simple interface it is offering you guys. Okay, yeah. So that is what. And these services are highly reliable and secure compared to all the cloud platforms, similar to the Google Cloud Platform and Azure Cloud Platform and AWS. All of these cloud platforms provide you the reliability, secure, and scalable infrastructure. And according to your requirement, if you wanted to scale up and down your infrastructure, you can go. And Google has an extensive global network of data centers available throughout the world. Google has its own data centers throughout the world. Even in India, also, we have two data centers. One is in Mumbai, that is nearby, and one more is New Delhi. So Google has its data centers in two locations. One is Mumbai, one more is Delhi region. Mumbai region and Delhi region, we have 2 data centers available. So Google has a plenty of data centers available throughout the world. So yeah, I'm not sure. You can check it out. Yeah. Okay, so that's how. So we have the region. So it is not only one region. Three zones will be there. Here 3 zones. Here 3 zones will be there. So that's how. Okay, so this is how Google is providing you the resources or services which are highly reliable, secure, scalable, and this infrastructure is available throughout the world. And sir, if you guys wanted to see a high level set of category of the services, you have it here again. Compute, just now I was talking about, right? The same thing: compute, IAM, management, networking, big data, storage and database, and machine learning. So these set of services that GCP is offering you guys. In each set, if you can see services like BigQuery, Dataflow, Dataproc, storage, Bigtable. So we are mainly focusing on the data engineering. So that's the reason we are focusing on these two. Okay, so big data and storage and database services, right? Yeah.